Hey, what's up, guys? This is Group 7. There's four of us: Jocelyn, Junchen, Agatha, and also Alia. On a random Thursday evening after we finished medical imaging class with Dr. Isha, we decided to have a walk around UM campus, and that's when we took pictures of the leaves that we find laying around, some cat just chilling, and also a random snail finding its way back home. That is when we came up with the idea to make a GUI to analyze the image that we took. In this video, we are going to explain the coding and the GUI that we designed. So let's go. Before we start explaining on the coding that we use to develop the GUI, we are just going to show the overview of the GUI that we designed. So this is how it looks like. We have the load image button for the original image, and we have the pre-processed image button, segment image button for the segmented image, and the result with the morphological analysis, and the value for area, circularity, parameter, and centroid. We also have an additional image description button where it will state the location and context of the picture. Firstly, we will perform callbacks for each button that we created earlier. So we are just going to explain one by one. Firstly, it's the load image button. So right here, as you can see, the global and global, you will be seeing a lot of global prompts in the rest of the coding. So global actually declares the global variable name A to store the image data, so it can be accessed from anywhere within the code. And the global file name is to store the path and file name of the loaded image. While line 39 actually display a file selection dialog box with the title Load an Image from UM Campus. So this part actually allows user to choose any file type. So it will come out as a pop-up window for you to select any image. The str code is actually used to create a full path to the image. Line 41 actually reads the image specified by the file name variable and store its data in the A variable instead. The imShow variable is used in the SPROM to show the image stored in A into the first box of the load image that we saw earlier. Onto the pre-processed image button, we can see the global prompt again. It is to store all the variable, and then we have the if size prompt. Actually, this part is to check and convert the grayscale. So if the size A3 equals to 3, the image has 3 color channels, so we want to convert it to grayscale by using the RGB2 gray code. Otherwise, we leave it as it is, meaning that if the picture is already in grayscale, we leave it as it is. Next, we have the binarize the image. We use the imbinarize prompt to convert the image to black and white using default threshold. For the next part of the coding, actually we apply specific processing image based on the different pictures that we took. Firstly, if the file name contains cat.jpg, we will adjust the contrast by using the imadjust prompt, and then we will convert it to double by using the im2double, and lastly we will apply the logarithmic transformation. As for the file name that contains leaf.jpg, we will use the BWR open to remove the small objects of the image, and then invert the image using the prompt in complement. The plan.jpg actually has the similar prompt to cat.jpg, but we are using a different gamma value here, where we use gamma value 4 instead of 0.85. For the rest of the picture that is being uploaded in the GUI, we will just adjust the contrast by using the imadjust prompt, and then we will use the prompt im2double to convert it to double. Moving on to the segment image button. So just like the pre-processing image button, we also have different prompt for different file image. The first part, as usual, we will declare the global variable first. If the file name contains cat.jpg, firstly we will binarize the image. We will convert the current image to black and white using default threshold, and then we will invert the black and white pixel and create a negative image by using the incomplement prompt. Next, we are using the prompt Strel to create a structuring element with a vertical line shape. It has a 5 pixel long and it is oriented at 90-degree angle. With the prompt I am close, we will close the gaps in the black region of the BW1 using a vertical line structuring element. So with this, it will help to connect the fragmented edges. We will also use the I am fill prompt to fill any holes, meaning that if the white region is completely surrounded with black, we want it to fill the holes in to create a solid object. After that, by using the BWR open, we are going to remove the objects with the area smaller than 100 pixels. Next, we create a structuring element with a diamond shape. It has 15 pixels in width. And then by using the I am dilate prompt, we want to expand the black region of BWW outwards using the diamond structuring element, so this can slightly enlarge the object. Lastly, we will erode the image. We will erode the black region of BW5 inward using the same diamond structuring element where we can refine the edges and remove any small protrusion. Overall, for the cat, actually we perform a series of morphological operation where we did the closing, filling, opening, dilation and also erosion in order to refine the image feature. So we are likely aiming to isolate the cat shape. If the file name contains plan.jpg, firstly we will binarize the image. We will convert the image to black and white using a default threshold, and then we will invert the black and white pixel to create a negative image. Again, we use the incomplement prompt, and then we remove any object with area smaller than 100 pixels by using the BWR open. And then we want to fill the holes by creating a solid object. So this part where we can help to merge any fragmented parts of the plan by using the I am fill prompt. And then we create a structuring element. Next, we will close the small gaps in the black region using the vertical line structuring element. And finally, we will fill any remaining holes to ensure that all the plan objects will be fully connected by using the I am fill prompt. Now, if the file name contains snail.jpg, these are the prompt that we use to segment the image. So at this part of the coding, it is actually quite repetitive from the previous one, which is the cat and also plan. So we are just going to go through it very quickly. First, we will binarize the image, and then we will invert the image, and then we will fill the holes of the image, and then remove any small objects that has area smaller than 100 pixel, and then we create a large diamond shape structuring element. So for this, we are using a 200 pixels in width because we want to help connect broader regions of the snail. And then we close the gap by using the diamond structuring element, and then we create a vertical line structuring element, and then we dilate the image, and lastly we will erode the image to define the edges of the snail contour. Last part of coding for the segment button is if we put any other pictures other than the snail, cat and also a plant. So we are using the prompt I'm fill to fill the holes. And then we create structuring elements. We use diamond first with a width of 10 pixel, and then we use square shape structuring element with a pixel 5, and then we dilate the image, and then we fill the holes again, and lastly we will erode the image to again refine the edges. We are almost coming to the end of the explanation on our GUI, so now we are going to explain on the results button. Starting off with the calculate region properties, where we create a prompt to calculate properties of each connected region. So we calculate the area, which is the number of pixels in each region, and then their circularity, which is how close the region's shape reassemble a circle. So if the number is moving closer to 1, it means that the image has a perfect circle. And then calculate the perimeter, and also the centroid, which is the region of the center coordinate. And then we create a prompt to extract the centroid coordinate from the stats. And then line 139 to 142 is actually the prompt to display image with overlay. So what is going on here is that we wanted to plot the red stars at the extracted centroid coordinates on top of the labeled image. With the overlay code that we include in the coding, we are able to see a blue shadow on the object of the image. So this actually indicates the segmented area. Finally, we came to the special button that we created to give the description of the image. So for this part of the coding, we create a button that we can click, and then it will reveal the location of where we took the picture of the image, and then context of the image is like what the image is trying to tell you. We have finally came to the most fun part of this video presentation, which is actually running the code and see whether it works or not. So here we are clicking to run, and since we are using MacBook Air, so it's a bit slow and it takes around like 50 seconds to get the code run, and this is what came out after the run is completed. And yeah, this is our GUI. It looks pretty nice, so let's see if it works by testing the load image button. So we're going to click the load image button, and a pop-up window will come out, and as you can see, there's 4 pictures that we took, and we're going to choose cat for the first one. So we load the cat image, and then we click the pre-processed image, and then segment image, where we invert the colors to black and white, and then the result, where you can see there's a centroid at the picture, and also the image description, where it states there inside tower FOE, and context is a cat sitting on the floor. And then we try onto the other image. We try the plant. Now we segment it, and then we see the result, and the image description is a plant with long leaves. This picture is taken at College Kediaman, Tunku Bahia. And then moving on to another picture, we try onto the leaf now. Now we process the image, segment the image, and then show the result. You can still see the centroid in the middle over there, and then the location is in front of engineering tower, and it is a piece of leaf. Lastly, snail.jpg. So we load the image, and then we pre-process the image, and then segment it, and the result, you can see the centroid there, and then we click image description. That is all for our presentation, and I hope you enjoy it as much as we did in designing the GUI, and hope to see you guys in the next coding session soon. Thank you for watching.